Start with the name of Allah, the most merciful and mighty. My name is Maaz and you are watching Maaz Academy of Physics. In the previous class, we studied about the Coulomb law in detail. Then we studied about what is electric field, and then we studied about the electric field intensity. Today we will talk about the representation of electric field line, that how we can represent the electric field line. So let's start how we can represent the electric field line. Take two charges, for example, we take two charges, both have positive charge. So when they come close to each other, so what's happening? They apply force of repulsion on each other. Okay, they apply force of repulsion on each other. Why they apply force on each other? Is there is any contact force? No, because there is no contact between the two positive charges. So why they repel each other? Is there any gravitational force? No, because the charges have no mass. So how can they apply gravitational force? So what is there that they both charges apply force of repulsion or force of attraction on each other? So there is a region where both charges each other, so they apply force on each other, force of repulsion or attraction. This region is called electric field. This is the region of both charges when they interact with each other, so they apply force of repulsion. If they have same charges, mean both are positive charges or both are negative charges, so they will apply force of repulsion on each other. Okay, if one charge have positive charge and other negative charge, so they will apply force of attraction on each other due to the electric field. Okay, let's take a charge, for example, positive charge. So this charge emit a photon. This charge emit a photon. Photon means it emit the light in the form of packet. So this charge emit a photon, and this photon is called virtual photon. Why this photon is called virtual photon? Because this photon emit very quickly. When this photon move from one point or transfer from one point to another point, so we cannot detect it. That's why this photon is called virtual photon. Virtual photon. Okay, so we cannot detect this photon. So how can we say that there exists the electric field or not? So we take a positive test charge here. If we take a positive test charge to check that there is electric field or not. So when we take a positive test charge in this region, so what will happening? Both are positive, so this will apply force of repulsion on each other in this direction. So it means that there is electric field exists. If we take a negative charge, so what will happening? Positive charge in this direction and negative charge will be toward it. They will apply force of attraction on each other. Now how we can calculate the direction of electric field? So we use a test charge. Let's take a negative charge here, and this region we take a test charge positive. So what will happen? Both are opposite charges, so the direction of the arrow will be toward the charge. Okay, the direction of the arrow will be toward the charges, while in positive charge the direction of the arrow will be away from the charges, out of charges. Okay, ये तो आइसोलेटेड चार्जेस की बात थी. अगर हम दो चार्जेस ले एक साथ, मसलन दोनों पॉजिटिव ले, लेट वी टेक टू चार्जेस पॉजिटिव. ओके, both are positive, so this line will be same. Okay, this line will be also same, and this line will be like this. Because both are positive, so they will repel each other, so these lines will not attract each other, they will not cut each other, they will not interact with each other, because both are same, so they will repel each other. We take two opposite charges. For example, one is negative charge and other is positive charge. So as we know that the arrow direction in negative will be toward the charge. Okay, and positive, the arrow direction will be away from the charges. So both are opposite charges, so what will happening? Both will attract each other. Okay, we take another charge. Let's positive charge we take, and here the electric field line direction will be away from the charge. Okay, so if the electric field line are close to each other and its intensity is increased, so the electric field will be strong. If the electric field line are far away from each other and its intensity is low, so the electric field will be low. For example, if we take here this area, so what will happen? The density of this line is very high. The density of this line is electric field line is very high. So electric field here, the electric field will be stronger. Okay, if we take it here, so the density of this line, of these line is so weak, so the electric field will be low here. So this was a little bit information about the representation of electric field line. So hope you will learn something from this lecture.